Good evening.
Evening.
Yeah.
Yes, sir.
Sure, sir. A very pleasant afternoon to all. I'm Hemashri, Chairperson of Meeting Committee, ASC SVC Student Chapter. I would like to take the immense pleasure to extend a very warm welcome to all the students and faculty of Civil Engineering Department, Sri Vidyaniketan Engineering College, on behalf of ASC SVC Student Chapter. Today, we have gathered here for guest lecture on nanotechnology-enabled water filters, a sustainable way for point-for-use water purification by Dr. Shihabudheen Maliyekkal, Assistant Professor, Department of Civil and Environmental Engineering, Indian Institute of Technology, Tirupati, India. I would like to request Faculty Advisor of ASC SVC Student Chapter, BOS Chairman, Head of the Civil Engineering Department, Dr. O. Ishwar Reddy, sir, to address the gathering. Please, sir.
Good evening to everyone. So it's my pleasure to give opening remarks. So generally we use it to organize expert lectures and guest lectures under the roof of ASCE and IGS and IAS, Student Technical Associations. So it's a regular practice in the Department of Civil Engineering of Sri Vidyaniketan Engineering College. In order to showcase the recent technological developments in various fields and domains of civil engineering, both from academia as well as from industry. So in order to help the students to expose them to the new technologies that are happening, that are coming up within the industry as well as in the academy, what is research is happening, so how this research is brought into the practice. So these things, so students should be exposed. So that is the intention of this particular expert lectures and guest lectures. So within the curriculum, it may not be possible to bring the latest developments in the field. So with this particular platform, so we can able to provide students the latest developments in the field of civil engineering. So with this intention, so we tried Dr. Shihabudheen, so from Indian Institute of Technology, Tirupati. So he is one of the versatile researchers in the field of environmental engineering. So recently we met him at IIT Tirupati. So then later onwards I contacted him for an expert lecture. So he is very open-minded to accept our invitation to deliver the lecture. So I welcome you, sir.
Thank you.
Yeah. So I thank you once again for the opportunity. So go ahead.
Thank you, sir. Now, Yashashwini, corresponding secretary of ASC SVC Student Chapter, will take the opportunity to read the profile of Dr. Shihabudheen Maliyekkal, sir.
Thank you, Hemashri. It is my pleasure to read the profile of Dr. Shihabudheen Maliyekkal. Dr. S.M. Maliyekkal is an assistant professor, Department of Civil and Environmental Engineering, Indian Institute of Technology, Tirupati, AP. He earned his master's and PhD from Indian Institute of Technology, Madras in area of environmental engineering. The main focus of his research is to address the challenging task of providing safe water for all. The most significant contribution of his decade-long research effort is the development of a nanotechnology-enabled purification system for arsenic-free water. The technology has been implemented in the field and more than 1 million affected people are benefiting from the invention. He was also part of the team that has developed a point-of-use water disinfection that can provide clean water at 2 pies per liter. He has an extensive experience in the synthesis and characterization of nanoscale materials, including nanoscale carbon. Besides water and wastewater treatment, his interests also include developing green and smart materials for energy and building applications. Dr. Maliyekkal has authored over 70 articles in reputed journals and conference proceedings. Some of his products and recent research findings are highlighted in the world news. He is an inventor, co-inventor in 14 patents or 14 patent applications. His research articles are well cited and published in very reputed international journals. He is a recipient of Invention and Patent Award and the J.C. Bose Patent Award, among others. He has secured several research grants and he is PI and co-PI of 7 ongoing sponsored projects. Now, I'd like to invite today's guest speaker to start the session. Please, sir.
Yeah,
Good evening, Shihabudheen.
Yeah, good evening. Thank you very much for the nice introduction and the opportunity. And I thank Sri Vidyaniketan ASC Student Chapter for giving me this opportunity to interact with your students. So can you see the slides, right?
Yeah, it's clear.
So I'll just this pointer, I'll make it. So the topic what I'm going to discuss today is nanotechnology enabled water filters, a sustainable way for point of use water purification system. So as you all know, water is one of the most vital resource in the earth planet. It's a life-sustaining nectar, and its availability at the point of use is a prerequisite for sustaining human life and ecosystem. So every aspect of our life is touched by water, and it is too difficult for us to point out a single aspect of life which is not touched by water. So water is agriculture. So we use a significant portion of the water for agricultural activities. So water is infrastructure, right? A lot of water is required for infrastructure applications. So we are all civil engineers. We know how many, we know that concrete is one of the most widely used construction material, right? So we use around 150 to 200 liters of water for making 1 meter cube of concrete. And imagine how much amount of concrete we are making every day. Millions of cubic meters of concrete is produced. So how much water this particular structure is used. So you can imagine that. So the per capita consumption of concrete, if you see, it's more than the per capita consumption of the food. So there is a large connection between water and health. And right, apart from all this sector, the health sector also, it's very important as far as, you know, the fresh water availability is concerned. So you might have heard about Hippocrates, a very important figure in the field of medicines, right? He's considered as the father of medicines. And he mentioned in one of his literature that those who wish to investigate medicine properly, they should consider the water that the inhabitants use, right? We know that water-related illness are the major cause of human mortality in the world, especially countries such as, you know, especially most of the affected people are from countries like India. So we also know that water is a simple indicator of development. It is a sign of prosperity, right? Sign of calmness, sign of beauty. So we have also celebrated water, right? So we have celebrated water, dedicating large number of poems. We have written large number of articles on water. We have written large number of, you know, dedicated large number of different kinds of art forms. So, so all this we have done, but one thing what we have neglected is we have not given enough, attention to this particular resources, this particular precious resources, what it deserves. As a result of that, now we have a big problem of water scarcity and water quality, right? So according to estimates, more than 70% of water bodies in India are, contaminated. So more than 70% of the water bodies in India are contaminated with various kinds of pollutants. You can see that, inorganic, organic, and as well as pathogenic organisms in various water bodies across the country. So now we have several challenges to address. Right, we have several challenges to address in water sector, both in terms of water quality and in terms of water quantity. A lot of people around the world lack access to safe water, right? More than 2 billion people worldwide lack access to safe water. So a majority are from, developing countries like India. So We also know that water-related illness are the major cause of human mortality in the world. And if you look at the data, and every 2 minutes, a child below 5 years die due to waterborne diseases. If water is not available at home, women and children, especially girls, are responsible for collecting water for their families. According to data, mother and children around the world spend 200 million hours each day collecting water. So compared to other people, these are the two people who are largely affected because of water scarcity and water related issues. So this prevent girls going to school, right? If you can provide adequate amount of water at the point of use, you can save lives of several kids worldwide, and you can give them good future. So apart from that, providing food, proper sanitation facilities also very important to protect their health and improve their safety. So you can also see several other aspects related to water. So if you look at the people who are affected because of water related issues, mostly are from rural areas, as I mentioned to you earlier, rural areas and urban slums. And 68.5 million people who have been forced to flee their homes doesn't have adequate access to water, and several women die every day from complication in pregnancy because of lack of access to water. So I just wanted to highlight some of these issues. Why? Because so we are now facing a lot of difficulties because of the ongoing pandemic, right? So we also understood that, like, we also know that the entire world is shut down as a result of this pandemic, and how much money we are pouring to address this particular issues. But if you look at the number of people who have died as a result of this pandemic, and the number of people who are died just because of lack of access to water, so you can compare that. So that will give you an idea like how much importance we need to give to address this particular issues, right? So so if you look at some other reports published in various articles, so you can see that every year more people die from the consequence of unsafe water than all forms of violence, including war and terrorism. So that shows a lot of people are dying every year because of water related illness. And some of the data shows that around 3.75 million people are dying because of water and sanitation related issues. And a significant portion, around 46% of that, is just because of diarrhea. So now, so as we understand that we have several issues in this sector. So we have issues with water, pollution, the quality of the water. We have also issues in terms of quantity. I just wanted to, show you some of the data related to the water quantity. So what is shown in the slide is that how much water demand from various sectors, right, in our country. So we need, including irrigation, drinking, and other sectors, right? So this data was published by Ministry of Water Resource. Now it is Ministry of Jal Shakti, right? And National Council for Integrated Water Resource Development. So you can see two, plots. So from this data, what we can understand that if you look at the water demand, these organizations have projected over the last, next 30 years. So we can see that each sector, the demand is increasing significantly. Energy sector, if you see, like if you compare the data from 2010 to 2050, there is a around 13 to 16 times increase in demand. So what it shows, so the water demand is increasing in one side, but other sides we have a decline in, availability of the water. And on the top of that, we also have the problem of quality, right? So if you look at the availability, the water required, in the next 30 years, so if you compare from all the sectors what I have listed in the graph, it amounts to something like 1,400 billion cubic meters. But what is available from runoff is something like 1,900, approximately 1,900 billion cubic meters. And so what is usable water in that is around 1,100 billion cubic meters of water. And we also need to understand that this 1,100 billion cubic meters of water is available during the monsoon seasons, and we don't have adequate facility to store, that much amount of water. A significant portion of this water will go wasted, right, into the sea, and we don't have adequate storage capacity. For all the storage capacity put together, what we may be having is, less than 300 billion cubic meters of water. So is it possible for it to manage that kind of a demand in coming years with this much amount of water? So what is the solutions for that? That is what we need to think about. That also shows, the importance of this particular sector. So we also need to understand that we have a dedicated ministry to address the problem related to water. So water related issues is clearly reflect the challenge that we are facing in our country as far as water availability and water pollution is concerned. So I just wanted to give you a brief idea about various kinds of pollutants of concern in our country. There are several kinds of pollutants. You can see all kinds of things in water. But I'm going to restrict my discussions to some few pollutants in water, especially which are very much, related to our country. So we know that, most of the water bodies across the country are polluted, correct? So we have all kinds of pollutants in water. And one of the major reason for pollutions, what CPCB has, various researchers have highlighted, is the disposal of domestic wastewater. So we know that we produce around from, cities around 62 billion cubic meters of wastewater per day. And out of this only, if you look at the treatment capacity, what we have, the installed treatment capacities, what we have is only 37%. Right? So out of this 37%, many of the installed treatment plants are not functioning. Only 66 to 70% of the plants are functioning. So you can imagine that if you do the calculations, what we can, and we understand that more than, so we treat only less than 20% of the water, and remaining 80% of the wastewater is, untreated or partially treated and let out into the environment. So this is one of the major reasons for water pollution. You can attribute several other reasons, right, to water pollution, industrial discharge, and, including, cultural practices, what we follow, then behavioral practices, and so many issues you can correlate. But one of the major issue is this. So we have, when you talk about fresh water, we know that fresh water is very limited, right? So we all know about it. So what is available for use, it's, if you look at the freshwater quantity is less than 1%. So we have to manage the entire shore with 1% of water, right? And then again, this fresh water, it's a portion of the fresh water is, in ground, and a portion is in surface water. So we know that groundwater is used extensively in our country, right? Especially in rural areas. More than 80% of the rural drinking water demands are met by groundwater. So groundwater is actually more reliable compared to surface water, because it's not directly exposed to the environment. So it is considered as free from pathogenic organisms. So that's one of the reasons why many parts of the world people use groundwater as one of the major source of drinking water. Now we have realized that there are a lot of pollutants present in groundwater, right? So now we have the problem of arsenic, we have a problem of uranium, you have a problem of fluoride. So all these kinds of pollutants are, present in groundwater beyond, at very high concentrations, beyond the permissible limit. So one of the major pollutant of concern as far as our state is concerned, as far as our country is concerned, is fluoride, right? So if you look at the data published, you can see that more than 60 million people in India are, exposed to fluoride contaminations, and 25 million people are at the risk of fluoride contaminations. And so we have fluoride in almost all the states, and fluoride is also present in various other parts of the world, right? You can see that in the plot. There are several countries which are affected by fluoride. So, but I wanted to restrict my discussions to our country. And one, in Andhra Pradesh is one of the major, the mainly affected states in India as far as fluoride contamination is concerned. In some of the places, if you see in Andhra Pradesh, the fluoride concentration is as high as 30 milligram per liter. It's much, much more than the permissible limit of 1.5 milligram per liter. So there are a lot of health issues people have reported due to chronic consumption of fluoride contaminated water, right? So some of these things are, we are all aware of some of these things, the dental fluorosis, right? The skeletal fluorosis, even it can create, cancer like bone marrow cancer and things like that. So this is one of the pollutant of concerns, and arsenic is another pollutant of concerns. Fortunately, in southern part of the country, we don't have much cases of arsenic. But, so we have a problem of arsenic in various other states, right? Northern states, especially in that Ganges plain. So West Bengal is the most affected, state as far as arsenic contamination in groundwater is concerned. When you compare arsenic and fluoride, we know that arsenic is much more, very, very toxic pollutants compared to fluoride. So the removal of these kinds of pollutants are very much required, because most of the water bodies in these states are contaminated with these contaminants, right? So you don't have any other options apart from treating water, right? And to meet the drinking water demands of the people. So that's the reasons why, you need to have advanced treatment technologies to tackle some of these pollutants in water. So if you look at the health effects of fluorides, so there are several health effects people have reported, right? So both cancerous and non-cancerous effects, right? It's one of the deadliest pollutant present in water, and several people, more than 7 million, people in India are, affected by fluorosis, including 2 million children. And our neighboring country, Bangladesh, is much more affected, and almost all the districts in West Bengal is affected by arsenic in groundwater. So you have other kinds of pollutants as well, organic pollutants like pesticides. So high concentration of pesticide is, detected in surface water in several places across the country, and even people have detected concentration of pesticide, small amount of pesticide in blood samples, breast milk. And one of the study conducted by Center for Science and Environment in 2003, they have analyzed various, drinking water bottles and what you see in the market, right? So including some of the top brands, and they found that almost all the, water bottle, drinking water bottles are contaminated with small concentration of pesticides. And they've also analyzed around 36 soft drink samples of 12 brands, right? So they found, organochlorine pesticides like lintane and DDT in almost all the samples. So that shows the, the spread of contaminations, and even after the several treatment, because many of these top brands, follow strict treatment protocol, but even after that, you're not in a position to remove pesticides completely from the water. Okay, so, and it also shows how widespread the problem is. And bacterial contaminations, some of the pollutants what I have shown before, so be it arsenic or fluoride, right, they are kind of regional pollutants. You have these kinds of pollutant in certain pockets, right? But bacterial contamination, right, or pathogenic contamination is a very widespread problem. It's kind of, you know, a national pollutant. It is present everywhere. And you also need to understand that, most of the deaths happening worldwide, the majority of the water-related illness are because of bacterial or viral contaminations or other pathogenic organisms. So more than 2 billion cases of diarrheal infections are reported every year across the world, right? So if we can provide good quality of water, then we can avoid, such kind of problems, and you can save several millions of lives every year, right? So apart from these pollutants, now we have another major issue of microplastics in water. So we produce a large amount of plastics, right? And a significant portion of the plastics go into water bodies after the use. And if you look at the life cycle of some of these plastics bags, what we use, it's very short, right? And so it goes back to the environment. So we don't know what happens to this, right? We never think about what happens to these plastic bags when you throw it outside, and most of them will end up with the water bodies. And as a result of that, over a period of time, these plastics bags disintegrate, and then slowly you will have microplastics in water. Now people have identified microplastics in various water bodies across the country, and some of the report shows, if you continue disposing plastics into the water bodies, especially sea, the amount of plastic in the ocean is expected to outweigh the fish by 2050. So that you can imagine, so how much amount of plastic is going into the sea. So we always ask a questions, right? So why can't we recycle? Many of these plastics are recyclable, right? Theoretically speaking, most of the plastics are recyclable. We have technology also to recycle plastics, but we have various challenges recycling plastics. One of the major challenge what we have is, so you have different kinds of plastics in the market, right? You might have noticed a particular number like this, right? As I shown you on the slides, 1, 2, 3, and that indicates the kind of plastics used for making that particular product, right? So you have 1 stands for polyethylene terephthalate, then you stand for 2 stands for high density polyethylene, 3 stands for polyvinyl chloride, and things like that. So, but what I am trying to tell you is when you take a water bottle, so its water body is made of certain plastic, its cap is made of certain plastics. So you have difficulty in recycling it because you have multiple plastics in one product. So in such situation, the properties of these plastics are different. So it would be difficult for us to recycle it in one shot. So you need to segregate it. So segregation is the biggest challenge what we are facing as far as the recycling of plastic is concerned. This is true for other products as well. For example, you take the case of a beer can, right? It's made of 3 alloys, right? So you have a particular alloy used for making the body, and the cap is made of another alloy. If you look at the concentration of the copper present, each alloy has 5, 6 elements in it. So one small can is made of several elements. So if I wanted to recycle it and extract these elements, it's not an easy task. The best example is your mobile phone. When the smartphone was introduced in 1983 by Motorola, so the number of elements present in that was something like around 30, 35. Now the smartphone, the recent smartphone, if you see, like the number of elements, right, what you have is more than 70. All right, it is like a periodic table you are carrying. Almost all the elements is present, because you need more kinds of features. For that, I have to use, different kinds of elements present in the periodic table to get new kinds of features, So that now when you talk about recycling it, how do I recycle these kinds of products, right? A kind of high entropy products. So it is too difficult for us to recycle such kind of things and extract, each element from the product. So that is one of the biggest challenge. There are several other challenges associated with such kind of products. So now what is important now is, so we have various kinds of products, we make various kinds of things, right? So one important question is what we need to ask: all these products are sustainable, all these products are recyclable, all these products are reusable. So it is very important for us to close the loop, and that is one of the reasons why most of the products, what you see in the natural products, are very sustainable, because the natural follows the principle of recycling, right? So the entire processes, most of the natural processes are closed processes, it works in a closed loop system. But most of the anthropogenic processes are open processes. So that's one of the reasons why most of our processes are not very sustainable. So when you develop a product, right, be it water purification based products or any other products, the most important questions what we need to ask is the product sustainable or not? So we have various kinds of treatment technologies available. So in the previous slides, I have shown you several kinds of pollutants, right, present in water. And some of these pollutants can cause various kinds of diseases, both cancerous and non-cancerous diseases. So we have realized that we need to have some solutions to address these pollutants, because majority of the water bodies are contaminated. So I don't have much options to bring water from other places, right? Water free from pollutants from other places, and sometimes it is not economically viable as well. So the only solutions what I have in front of me is to treat the water. So we have different kinds of technology. We also need to understand that many of these pollutants, if you look at their behavior, their physical and chemical behavior, they are very different. So you cannot address all the pollutants in the same fashions, right? So if you look at water, you have suspended solids in water, right? You have solids in water, solids of all sizes, right? You have dissolved solids, you have suspended, you have colloidal solids, and these solids behaves in a very different fashion, and they even settle in a very different fashion, right? So I need to have different strategy to handle them, and it's not that easy task. So now we have different kinds of pollutants, different kinds of technology, different kinds of materials available, right? So you have membrane-based treatment techniques, you have adsorption-based treatment technique, you have chemical-based treatment technique, right? So several things are available. So when we select a treatment technology, there are certain questions we need to ask, right? So we have several options. What options would be more appropriate for a particular conditions? So you also need to ask questions like, what is the feed flow rate? What is the nature of the solute? What kind of pollutant you wanted to address? What is the concentration you wanted to address? And you also need to understand what are the background ions present in water, that is the water chemistry, and what is the expected removal efficiency. And all these kinds of questions have to be asked, right? Then some of the questions like, socioeconomic conditions of the people, right? Affected populations, whether they will be in a positions to, afford the kind of technology what I am offering to them, right? And what type of water supply source is available in the affected area, or the affected area requires a centralized treatment system or semi-centralized treatment system, or can we go ahead with, a small scale, point of use or point of entry water treatment system or wastewater treatment system. And so we know that some of these technology also produce waste during the treatment process. So what sort of waste is produced? How do I manage the secondary waste, right? management of secondary waste produced. In the case of membranes, you have secondary wastewater produced, right? The reject water produced. How do we manage all? And of course, the cost and ease of operation is very important, right? So I don't prefer a product which costs me something like 1 lakh rupee, right? So it is not, nobody would be interested in spending 1 rupee per liter of water or 10 rupee per liter of water. So I expect water to be available to me for, free of cost. So the cost of treatment is very important, and apart from that, ease of operation and maintenance is also very important. So you have to look at all these aspects when you develop a product, and most importantly, you have to look at the sustainability, whether the product what you are developing is sustainable, is it environmental friendly, and right. So what sort of material you use, right? Is the material is how did you extract the materials, from where it is coming? So where it is going after the use, after the service life, and all of these questions have to be looked at, right? So to assess the sustainability of the product. And when you develop a product, it's also important because the end users are the public, and their public participation is also important. You need to take the feedback from them if you wanted to develop a successful product. Sometimes you develop a very beautiful product and go to the market. Sometimes the public perception about the product would be very different, right? So it is always good to have their opinion in developing products, and you need to provide what people want. So we have different options, as I told you before. You can develop centralized treatment systems, right? So you can semi-centralized treatment system, or you can also have a point of use treatment system. So most of my discussions, I would be, focusing on point of use water treatment system. So there are certain reasons why we prefer point of use water treatment system, especially in our country like India. So we know that centralized water treatment system, there are several challenges in establishing such kind of a system. So for example, capital investment, you need a lot of capital investment, right? You need skilled labor, and you need good governance, and you also need access to appropriate technology, and a large distribution and pipe distribution water supply networks are required. And sometime if the water is not available sufficiently, then you will have an issues. One best example is, we have a 530 MLD plant in Chambaram, right? Water treatment plant in Chennai. Some of you may be aware of it. Some of you would have visited that plant. So this plant is a 530 MLD plant. We visited this plant, last year. And so at that time, this was running 1/10 of its capacity. Right. So, but water is not available. That's the reasons why we cannot use the complete capacity of the treatment plant. So that is another challenge what we have. Then of course, maintenance, recontaminations, all kinds of issues, because you have to carry the water from a central place, right, to somewhere far away, several kilometers away, and during transport, there is a possibility of recontamination. All these kinds of issues are there. So that's one of the reasons why people started looking at other options. So especially point of use and point of entry water treatment systems. Some of the advantage of merits of using point of use water treatment system, it avoids the need of large capital investment, right? And management system. You don't need to have large distribution networks, right? Allow individual or community ownerships. So the maintenance would be much more easier compared to the large scale system. And it also allows involvement of end users in decision making and maintenance and other aspects of water. So that helps in running the system in much more easier and better manner compared to a centralized water treatment system. So you can see now large number of products available in the market, water related products, right? Water treatment products available in the market. So that shows there is a lot of business opportunity also in this particular sector. Now, there are several options I have shown you, right? So there are several methods of treatment. So we are all familiar with the term nanoscience and technology, right? So nanoscience and technology, we know that the study and application of extremely tiny things, right? Extremely small things. And it has application in all field of science and engineering. So nanoscience materials are used in medical applications, energy applications, telecommunication, security application, right? Food preservation, environmental application, etc. Right? So it has large number of applications. So this particular concept was, first introduced, in 1959 by Richard Feynman. So through his talk, there is a plenty of room at the bottom, right? At an American Physical Society meeting at the California Institute of Technology. That's called Tech, right? Then actually, after several years, the Professor Norijo Taniguchi from Japan, coined the term nanotechnology. It is actually coined in 1974. So the modern nanotechnology started in 1980s with the development of scanning electron microscope. Previously, we didn't have enough facility to look at, the materials in nanoscales, right? You cannot use optical microscope for that purpose. You need to have an electron microscope. So development of scanning tunneling microscope has enabled, us to see individual atoms. So now we are in a position to control individual atoms and molecules, right? So the last 3 decades, if you see the nanoscale science and technology has evolved significantly. Now we have the ability to manipulate and characterize materials at levels of, single atoms and small group of atoms. So now we have, understood that this nanoscale manipulation of the material will also enable us, development of materials and system with unique physical and chemical and optical properties, and it has large number of applications. So unlike conventional bulk materials, if you bring down the size of the particles in the range of 1 to 100 nanometer, the properties of the materials, changes drastically, and the material size, the properties are site dependent, in this particular size regime. So that is why there are several reasons for that. One of the major reasons it is, large surface to volume ratio, and this, how this nanoscale materials interact with outside environment. It's much different the way the bulk material interact with outside, the environment. So when you bring down the size of the particles to, smaller, for example, as you see here, it's a 1 centimeter cube, right? You have 1 mm cube and 1 nanometer cube here. And if you bring down the size to from 1 mm to 1 centimeter to 1 mm, so you can see that I can pack around 1,000 cubes inside this same box, right? And if you look at the area of this cube is something like 6 centimeters square. Here it becomes 10 times higher, right? 60 centimeters square. So if you bring down the size to 1 nanometer, that means I can pack something like 10 raised to 21 small cubes of size 1 nanometer in this 1 centimeter cube, and you can increase the surface area around 10 raised to 7 times. So that shows, you can increase the surface area. Surface atoms are much more reactive. You can change the properties of the material, reactivity of the materials, and things like that. So you can, you can explore, you can utilize that properties at nanoscales for various applications. So as I told you, so most of our works are, directed towards developing sustainable nanoscale materials, because we know that when we make nanoscale materials, it has a lot of other issues because they are very reactive, and if it goes out, so we don't know exactly how they are going to interact with the environment, right, over a period of time. So you need to have technology to prevent that. You need to have nanoscale materials which are very sustainable. Otherwise, down the line, we will have major problems because of presence of nano materials in your environment, including water bodies. So some of the questions what we ask when we talk about developing materials is be it nanoscale materials or nano or non-nano based technology or materials. So whether the material is sustainable, material sustainability is actually very important, right? So we know that we extract materials, right? Then we process it, we manufacture it, we use it, then finally it will be discarded, right? So, so is the material what I'm using it replenishable or not? That is one of the questions I need to use. We should think about using replenishable materials instead of non-replenishable materials. So that's very, very important if you wanted to develop something which is very sustainable. So even if it is replenishable, you have to ask a question at what rate it is replenishable. So you need to compare that with the consumption rate of that product, right? If the consumption rate is more than the replenishability, then it is not sustainable, right? So that's very important. So you can also ask questions, is it possible to reuse it? How many times we can reuse it? Every material has a finite life, and finally it has to go to the environment. So when it goes to the environment, what happens to the material, right? Is it toxic? What way it will interact? What is the fate of the material? Is it biodegradable? So all these kinds of questions you need to ask and make sure that the material what you use is very sustainable, right? And you should follow a closed loop system, and as much as possible you should not allow things to go out, right? So that's very important. So closed loop, closed cycle is very much important. So we have developed various kinds of nanotechnology enabled water purification system. I restrict my discussions to water purifications because nanoscale materials have a lot of other applications. So what we are concentrating on, is it possible for us to use these kinds of material for, some socially relevant applications like water and wastewater purifications. So we have developed a product. This is basically a metal oxyhydroxide based product in which an antibacterial material is incorporated, right? What you see here is a cartridge made of aluminum oxyhydroxide or iron oxyhydroxide. So this actually forms, so we have used actually a civil engineering concept here. Actually this material is prepared in a certain fashion. So we have used a kind of a polymer, a natural polymer to develop this metal oxyhydroxide nanoparticles. So I've used a template called chitosan to produce it. So this behaves like a reinforcing agent, right? We make fiber reinforced concrete, right? So similar fashions, we have made this nanoscale materials. So here, the fiber reinforcement what we have used, the biopolymer what we have used will act as a template, and it assists in the synthesis of very small size nanoparticles, right? It assists in the crystallization of the particles. It also gives you a lot of strength. So you can bundle this material and you can make it as small granules, and you can use it as a granule. It has a very large strength, right? So it is not very small size, but it is like, as you can see here. So this is the kind of structure, all right? So you have a fiber. On the top of the fiber, you have a lot of small particles attached to it. So as a result of that, your nanoparticles will not go out. So if you look at in a small, in the closer scale, you can see that all of them are, small nanoparticles, and it will give you the benefits of nanoparticles. But if you look at, as a whole, this material, it looks like a big granules, looks like sand particles. So you can also see that this is actually a scanning electron microscope. A lot of fibers are there inside, right? You can see that a lot of fibers inside. It's reinforced. So the integrity of these granules are very high. It behaves like concrete. And as a result of that, I can also use it, I can recycle it very easily. So I can use it as a fine aggregate in concrete. So at the end of its service life. So we have all these kinds of advantage with this kinds of material. So we have now we have incorporated an antibacterial material inside to this structure and use this aluminum oxyhydroxide as a substrate and developed a system which can release the disinfectant at a controlled and sustained rate. And at the same time, this, the cartridge can also remove heavy metals and various other kinds of pollutants. So what you see here is a small product which can deliver water at 2 paise per liter. And this work was done some time back. So we have used a similar kind of materials and for fluoride removal, and we have even tested it in some place of Andhra Pradesh, but this project was funded by Sai Baba. So we have tested it in some places here as well. So this is also a similar kind of material, and this material has a very high fluoride absorption capacity, and it is 5 to 7 times higher than the conventional activated aluminum. So we have made our cartridge out of it. We have made granules. You can pack it in, in a packed bed and use it at different forms. You can make it. So the good thing about this material is that because of this reinforcement, you can also shape it. So we have made it in different shapes, and we have added various other flavors into it, and to give different kinds of properties. So then a company was incubated in IIT Madras. It's founded by Professor Tirupati, and they have now started synthesizing some of these materials in large scales, and they have implemented it in the field, right, and several parts of the country. So several people are getting benefited from in the technology. So now, as I told you, so we always think how we can, close the loop when we develop a technology. So we all know that all these kinds of materials, what I'm talking about, all the products, what I'm talking about has a finite life. So at the end of the service life, it has to go somewhere, right? Though we can reuse it multiple times, but there is a limit, and beyond that, you cannot reuse it. So what we then it has to go to somewhere, and it has to go to the environments. And what would be the fate of that? That is the questions we always ask. So we have started exploring that, and we started looking at other possibilities of using these kinds of materials after, once you finish certain service. So now some of these oxyhydroxides we have converted into moisture absorbing medium. So if you see here is some kind of an humidification system we have developed, right? You can dehumidify air using this material. So you can use it for water purification applications. Once the application, once its service life is over, you can use it for other applications with a little modifications, right? So even the original material can also be used for the same purpose. And even you can harvest water from the atmosphere. So that is also possible because it has a large capacity to absorb water. So you need to do certain modifications to the material. So small modifications will enable you, different kinds of properties, that leads to different applications. So this is, you see this is the kind of material what we are using. It looks like a bundled firewood like structure, right, with lot of holes, right? That's one of the reasons why it can hold a lot of water into it, and it acts as a very good dehumidification system. And we have compared this material with the silica gel, one of the most widely used dehumidifying agent, right? So what you see here is the SG, the black color line. It is silica gel. It got exhausted. You see the capacity is something like 20%, 30%. And the material what we have developed is, it never got saturated. And So that is the kind of capacity we are talking about. So that's the kind of material we are talking about. So you can see that, it gave a consistent performance over several cycles. It works at, different environment, and also you can desorb the water very easily. You can reuse it multiple times, desorb and absorb, right? So even you can desorb it at low temperature. That is actually a very important property, right? So you can even use waste heat for that purpose, because the temperature has to be less than 100 degrees Celsius if you wanted to use waste heat for regeneration purpose. So these kinds of materials can be used for different applications. What you can think of as, a cooling system, desiccant-based cooling system, maybe in refrigerations, and several such kind of applications. You can think about the use of these kinds of materials. Now, previously I have shown you an antimicrobial material, right? So that material is used for disinfection of water. And so it is like a cartridge kind of a system, right? So when we deal with the cartridge, we have a lot of issues. One of the issue is the clogging of the cartridge. The pores will get clogged over a period of time, right? When you go to the field, you will have all kinds of difficulties. Then you need to have a pre-treatment. Then sometime you will have a lot of other background ions in water, right? So that may interact with your materials. There will be a possibility of clogging due to formation of calcium silicates because of scaling and things like that. So we started thinking about in a different directions now. Is it possible for us to make non-cartridge based system? So as a result of that, so we have now a kind of a filling kind of a stuff, right? So which enable controlled release of disinfectants. You can use it as a sachet, like your tea bags, and put it in water, and within few minutes your water will be decontaminated. And so there are a lot of results that have shown the most important aspects when you develop these kinds of system. What is important is you need to have a controlled and sustained release of your disinfectant from the system. So that achieving that controlled and sustained release of disinfectant is a challenging task, because you have to control several things. You have to control the porosity, and we don't want these disinfectants to come to water, at a controlled rate. Some of the disinfectants what we are using also not very friendly beyond certain concentration. So we need to control the concentrations within the permissible limit. So the data what I show here is, to establish the controlled release of, here we have used silver based nanoparticles inside. You can also use various other kinds of nano systems. Maybe you can use copper, a combination of silver and copper, or you can also use some other natural antibacterial materials and incorporate into these kinds of substrate and enable controlled and sustained release of the disinfectant to water. So we have established this material. We have looked at how these disinfectants are releasing into the environment, how stable they are, how long they will release, and all kinds of questions we have asked. And we also wanted to make sure that everything is within the permissible limit, right? Silver also has a permissible limit of 100 ppb. So it has to be within that limit. So we have achieved that by manipulating the material composition. So all this you see, if you want to know more details about these kinds of materials, I have already mentioned. Maybe I can share you the slides and you can go through some of this, published articles, and that would give you, much more detailed information about. So today's my idea is to give you an overall picture and what all the ways by which we can develop various kinds of products, right? So now these materials can be modified. You can put it on some reactor like this, especially designed reactor, right? You can pass water from one side, another side, you will get treated water, or you can coat it on sand surfaces and pack it on some material, on packed bed and use it. or you can even coat it on mud pot, right? The people don't have to buy separate reactors, correct? So you make this, it's kind of a paint-like material, and you can coat it and will form a film. So okay, it's a film formations will happen on the pot itself. Of course, there are several challenges in coating. So how do you coat? Coating has to be stable, and all these kinds of questions will come. But all these possibilities are there. So you can use this material in different forms. You can use it as a standalone film, right? You can carry you in your pocket and you can use it in traveling, or you can use it for household water purification purpose, and all these kinds of things can be done. So the good thing about this purification unit, no electricity is required, right? No disinfection byproducts, and it has a broad antibacterial property, and choking problem is minimized. I cannot say completely minimized. So here also the choking problem related to, right, due to the suspended solids are significantly minimized in this case. But there are issues like scaling, and so that we also have, now protocol to address scaling issues. So now you can also attribute different kinds of properties to this material. I'm just showing you a particular material and what all the ways by which we can use this material. You can add, fluorescence to it, and it can be used for security applications, or you can create certain kind of a pattern on this. You can create fluorescent pattern. It can use for certain applications, maybe security applications. You can put it on node, currency notes and things like that. So a lot of tracking system can be made, fluorescent tracking system, barcodes can be made out of it. So several such kind of possibilities are also there, right? Even you can use it for sensing, certain ions using this kind of films. It can be used as a sensor for mercury, and some specific ions can be sensed, right? So in some cases you need to do certain manipulations. So we have large number of materials. I don't know so how much time I have. So depending upon the availability of the time, I can move forward and hello.
Sir, continue, sir. No problem. Sir, this
So
Purushottam, sir.
yeah. So now, you see another, so far I was talking about some polymer-based composites, polymer metal oxide composites. Now we can also use carbon-based material, right? Carbon-based materials are available in plenty. So, we are all familiar with activated carbon, correct? So these activated carbon based materials are extensively used in water purifications. And now we have another allotrope of carbon, that is graphene, and some of you would have heard about graphene. It's a single layer of carbon, right? So you might be knowing about graphite. If you take one layer from graphite, it's called graphene. Okay, so graphene has very unique properties, and so it can also be, it has a very large surface area. It has very good conductivity, right? It has very good thermal and electrical conductivity, and a lot of properties. The graphene properties are very different from their other forms of carbon, right? So it also has a very good application in water purification. So we have explored the use of graphenic material in water purification, and so different forms we have done it. We have made graphene and supported it on various kinds of surfaces, and it is used for removing pesticides. It's actually, what we found is it's a very excellent medium for removing pesticides. So the graphene, the reduced graphene oxide, what we have used for purification of some of pesticide, including malathion, methyl parathion, then some organochlorine compounds. We found that this graphene can accumulate pesticides more than its self weight. That is the kind of capacity. That is what you see here. So 1,200, 1,400 milligram per gram of pesticides. So you can treat large quantity of water with small amount of material. So I have a video, but I'm not able to play it here. So what you see here is a method of synthesis of graphene. We know that graphene is a nanoscale materials, right? It is impossible for me to use it as it is in water because of the difficulty in solid liquid separation. So you have to support it on suitable substrate if you wanted to use it for water purification application. So we started synthesizing it on sand particles, right? The in situ synthesis of graphene on sand particles from various, carbon sources. For example, asphalt, from sugar, and. So you can make graphenic material from asphalt, from sugar, and even we have started now synthesizing graphene from plastics and other waste, agricultural waste, and things like that. Because if you wanted to use these kinds of materials for water purification applications, you need to have method to create these kinds of materials in large quantity. The bulk production is actually very important. Correct. So without having, a synthesis method for producing these kinds of material in large quantity at affordable cost, we cannot realize the use of these materials in applications like water purifications. We are talking about very down to earth applications. So what you see here is, we are using this material, graphene coated, we call it as super sand, right, for cleaning Coca-Cola. I have a video, but it is not, playing. So maybe I can share you some of these things later. So now we have developed a method to make graphene in large quantity and bulk quantity. So it has applications. Now we are in a position to use these kinds of material in water related application. Of course, we can also use it for other civil engineering applications, right? People started exploring these kinds of material for improving the the strength of concrete, compressive strength of concrete, flexural strength of concrete. So small concentration of these materials can significantly enhance the mechanical properties of concrete. So people are looking at this. So what I'm trying to tell you is that it has various other applications. But if you wanted to realize the applications, you need to have affordable method to synthesize this material. Whatever be the nanoscale materials you are using, the most important thing is to have affordable solutions to make it in large quantity on industrial scale. So then these kinds of materials we have modified, right? Different derivatives of these materials we have prepared. So you can decorate these materials with various kinds of nanoparticles, right? Metal nanoparticles. You can synthesize metal nanoparticles, for example, silver, gold, platinum on the surface of this graphene. So you don't have to have, additional reducing agents. This graphene itself behaves like, it has an inherent reducing ability. And so simply by spiking with corresponding precursors, you can create nanoparticles on the surface. Well dispersed nanoparticles of control size can be created on the surface, and it has a lot of applications. One of the applications what we have explored is degradation of pesticide again. So in the previous slides, I have shown you graphene-based materials can be used right for accumulating, scavenging pesticides, but it is a purely a kind of adsorption-based technique. Your pesticide is still there on the surface, and you need to have a mechanisms to take it out. If you wanted to use the material again for water purification. So what we did, we have decorated this material with certain nanoparticles. Now these nanoparticles can degrade the materials on the surface, so that so now your the graphene is available for the next cycle of adsorption. So the both adsorption and degradation happens when you modify this material with when you make composite materials, composite of graphene and metal nanoparticles. So that is what we have shown in this paper. So what I've been showing you is various kinds of products and materials what we have developed over the years for water-related applications, and now we have also started looking at other possibilities of using these materials, especially civil engineering applications. Can we use it as anti-corrosive materials? So we have also developed certain sealants, right? Many of these sealants or anti-corrosive materials are developed, the only reasons we have started looking at it is because we wanted to recycle it. We wanted to close the loop, right? So we use it for certain applications. Then after that applications, the questions what we ask, what we can do with this material. So those kinds of questions have resulted in new kinds of products. Now we have very biocompatible sealants for healing micro cracks in concrete, and not able to share the data because the publication and other things are going on. That's one of the reasons why I have not put it here. And now you have anti-corrosive, you can put it on steel, and which has a self-healing property, right? Many of these paints what you see can also be used, correct, the conventional paint, but something happens to the the surface. If there is a crack, right, then you will have a accelerated corrosion. So what you needed is a self-healing property. Even if you cut the surface, the material itself will take care of it. So it will automatically fill the gap. So those kinds of materials we are looking at now to make, to create self-healing properties and things like that. So not only environmental engineers, even civil engineers also have a lot of applications when it comes to nanoscale materials. And I hope some of you would be interested in looking at it, and so in case of any help needed, right, any guidance needed, so we are all here. So your faculty members would be there, and what is most important is interest has to come from you. Otherwise, nothing will happen. I know that many of you are very talented, right? Many of us have a lot of talents, but only issue is we are not ready. A lot of hesitations, a lot of resistance to come forward and start something. And you also need to understand that developing a product or doing research is not an easy task. One has to put sustained hard work, right? Such kind of people only can succeed, or such kind of people only can come forward. The talent alone is not sufficient, and we also need to be ready for working very hard, and that too very sustained hard work is very much required. So with this small note, so I also wanted to tell you what way we need to move forward now. So we understood that as a concluding remark, what I wanted to tell you is, so we understood that water is a very limited resource, right? And the demand for water is increasing day by day. So now we realize that there is a large disparity in demand and supply in various cities across the country, right? A lot of, more than 60% of our, cities are now water stressed. So in order to meet this increase in demand of water in various sectors, including agriculture, industry, energy, and domestic sector, I have shown you the data, correct? So how the demand is increasing in all these sectors, right? It is growing exponentially day by day. And so we have to take a lot of conservation measures. So what I am trying to tell you is that developing treatment technology is not the only solutions. Of course, we need to have, advanced technologies. We need to have affordable technologies, and we need to have sustainable technologies. But it's also very important to conserve water. Conservation measures have to be taken very seriously. So the measures such as rainwater harvesting, right, protecting water from pollution. So all these can be done by ourselves, right? Promoting scientific use of water resources, promote recycling and reuse of water, right, at individual level, institutional level, and various scales we can do that, right? Then, of course, developing advanced and sustainable technologies to promote reuse and recycle, right? And recovery of water. So, and also it is also equally important to develop comprehensive water policy, and that should address water related issues in a holistic manner. So when it comes to technology, nanoscale materials, so the concluding remark, play a significant role in resolving various water qualities, and we have a lot of scope, in developing advanced water treatment system using nanotechnology and nanoscience. With this, I'll stop my lecture, and I would be happy to take a few questions from the students.
Thank you very much, sir, for sharing your words of wisdom and throwing the light on the subject nanotechnology enabled water filters, a sustainable way for point of use water purification in a better way. Now I request all the participants to post their queries in the chat box of Zoom and YouTube platforms so that Manoj Kumar, President of ASC SVEC Student Chapter, will read them out one after the other. Please, Manoj.
Thank you,
1 minute.
Hemashri.
1 minute. Sir, could you
Okay,
please
sir. Okay,
stop
sir.
sharing, sir?
Yeah, I'm stop.
Yeah, go ahead, Manoj.
Okay, sir. Thank you, Hemashri. So here are the few questions, sir. First one, how safe is the use of nanotechnology for purification of water?
The safety, that's what I said. If you use nanoscale material as it is, there is a large problem because it is not possible for you to separate it from the liquid, right? So if you are using it, this material supporting on another substrate, so that then the technology is very safe. So you have to make sure that no nanoscale materials leach into your system. So there are several ways by which we can make that right now. So that is one of the example. What I have shown is an aluminum oxyhydroxide or iron oxyhydroxide, right? So we have created this on a template, correct? You have a polymeric material on which these nanoparticles are embedded, and it is embedded through chemical reaction, so it will not come out. So it will give you the property of nano systems. At the same time, it looks like a bulk material, so nothing will leach out into the system.
Here is one more question, sir. For municipality water supply schemes, will nanotechnology will be economical treatment?
So any technology, when you use water or wastewater treatment, you see, like every technology is not suitable for all the purposes. So you have to use appropriate technology. So you can use a municipality water treatment system, also nano-based materials. For example, so now we are talking about developing a capacitive deionization technique. So we use, it is basically an electrosorption technique. So this is actually a substitute for membrane-based technique. So we know that membrane-based technique has a lot of issues. One issue is it will say take out all the minerals, right? So many of these minerals are very essential for for us. And at the same time, it also rejects a lot of water. It's a place like Andhra Pradesh or Tamil Nadu, where we have a lot of water scarcity, and I cannot afford to reject 30, 40, 50% of the water, correct? So we need to have a kind of system for alternate system for RO. Now, according to this recent National Green Tribunal recommendations, if your input water TDS is less than 500 milligram per liter, you are not supposed to use RO-based system. So now we have a nanotechnology enabled capacitive deionization technique, which can do the same job. At the same time, you can also control the output water quality. You can retain some of the minerals. And this kind of system works at very low voltage, 2 volt, and such kind of a small power is only required. So these kinds of system can be used in large scale in municipal water treatment. So we have in IIT Tirupati 200 liter per capacity unit running. So we are using it in the mess. It's a nanotechnology enabled water purification system. Maybe some of you are interested, you can come and see that.
Sure, sir.
It's possible,
And
most important thing is when you use a technology and you have to ask certain questions. Sometime I cannot go and use membrane-based technique in rural areas or urban slums, right? So, but because one of the biggest question, even if you have enough amount of water, so the cost is very high. So they cannot afford. So you need to have an appropriate technology for them. But similar kind of technology can be, used in elsewhere, especially in cities where people can afford it. So every technology has its own limitations. Every technology has its own advantage. So we need to understand that, limitations. And you also need to understand various other factors, as I mentioned to you in the lecture, right? The water quality parameters, the perception of the people, and all these kinds of things have to be looked at. What kind of secondary waste are produced and how do we handle it? So, right, handling secondary waste will not be easy at a household level, but it may be easy at a centralized level. So all these kinds of questions have to be asked before taking a wise decision.
One more, sir. What is the status of use of herbicides in the process of treatment of water nationally and internationally?
What is most of the water treatment plant, what we have, conventional water treatment plants cannot remove, organic, pesticides, organic pollutants like pesticides. But of course, if you have additional carbon-based filters, so that can take care of to some extent. But some of the water purification unit, if you go to Chambarabakam water treatment plant, you don't see a carbon adsorption system there. And we know that a lot of water comes from to the lake, the Chambarambakam lake from agricultural runoff. So you will have pesticides in water. So, but the plant is not designed for removing pesticides. So there is a possibility that pesticides would be available. So that is what exactly I have shown in the slides, right? The studies conducted by Center for Science and Environment in 2003. So they have analyzed, your bottled drinking water. It has gone through various kinds of treatment, including RO, ozonation, but still small amount of pesticide they have found. So it's very likely that many of the water will be having pesticides in small quantity.
So here is the last one, sir. Is there any solution in nanotechnology for degrade of plastic waste in water?
There are degrading of plastics waste in water. There are nanoscale systems. People are using it for degrading plastic. Even there are bio-based methods people have developed for degrading plastics. But none of these technologies have not come to in the large scale. So now people are also started looking at converting plastic to usable materials, right? You can extract oil from plastics, you can convert that to graphene, and even we are doing some work on that. And so it can be done. So you can also think about, instead of simply converting it, what we need to think about, is it possible for us to use it? It's actually a raw material, right? I can use it as a feedstock and develop something else. Instead of wasting and degrading it.
Sir, I have a question.
Yeah.
So there are umpteen number of technologies that are not validated in the industry. So which are not validated by any of the agencies, but they are commercially available. So how to ensure the validation, sir?
Yeah, it has to go through validations. Without validating, you cannot bring into the market. There are certain protocols you need to follow when you want to bring the product to the market. Without that, you cannot. There are NSF protocols and things like that. So you have to do it. You have to establish. Then only you will get the certifications.
Thank you.
So there are several products in the market which are not validated, and we should not go and buy such kind of products. They are not
microbial based treatment technologies, especially as sewage treatment. They are not validated, but they are commercially available. Companies will come that we have technology?
Microbial technology or microbial technology for sewage treatment is well established. For wastewater treatment, you are talking about, or
Yes. No. Sewage.
yeah, sewage. That's what I'm telling you. It's a well-established technique, and most of our wastewater treatment plants, if you see, sewage treatment plants, we use biological methods for treating water. So secondary treatment unit, let's say either activator sludge process or some kind of attached trickling filters, all bio towers and all these kinds of systems are bio-based systems. So they are well established, and they have very activator sludge process and all extensively used. A sequential batch reactor, all of these are well proven technology, so it can be used. There is no issue on that.
Thank you. Yeah, go ahead.
Thank you very much, sir, for assisting and clearing all the doubts. And thank you, Manoj, for volunteering the question and answer session. Now I request Shruti, Vice President of ASC SVC Student Chapter, to deliver vote of thanks. Please, Shruti.
Thank you, Chemistry. As we have come to close this event, it is my pleasure to deliver vote of thanks on behalf of our team who helped to make this event a magnificent success. I wish to thank our guest speaker, Dr. S.M. Maliyekkal Garu, for sparing his valuable time in spite of this pandemic situation, and Dr. O. Ishwar Reddy Garu, Faculty Advisor of ASCE SVEC Student Chapter, and also Principal of SVEC and our management for their continuous support. I would like to thank the Coordinator, Office Bearers of ASCE SVEC Student Chapter, faculty, and students of Civil Engineering. Thanking everyone for participating in this event and helping to make this event successful.
Thank you, Shihabudheen.
Thank you all for the
For
patient.
your valuable. I wish you all the best, future interviewers.
Thank you.
We wish to have close association with you in future assignment.
Sure.
So I request you to cooperate with us, so our students may use your facilities whenever they require for project implementation.
No issues. It is our responsibility to help.
Yeah.
Right.
Thank you very much.
Public money, so it is not belongs to me. It belongs to everyone.
Yes, thank you, sir. Thank you for your words. So I thank and I appreciate the efforts of the ASC office bearers and its coordinator, Mr. D.V. Purushottam. So thank you very much.
Thank you all. So.
Yeah, sir. Bye, sir.
Thank you, sir. Thank you, sir.
Purushottam. Bye,
Sir. Yes, sir. Thank you, sir. Okay, bye.
Sweet.